Hello everyone, this is Jiachen. I'm recording this for ECE 6303. This is the problem 2. We need to calculate the density function first. So we use the same equation as mentioned above. We need to integrate the density function to be 1, but the trick is that the fxy is just a b, but the x can run from -1 to 1 from this photo here. So this is x, but y can only run from square root of 1 minus x squared, and there is a minus, and there is a plus, square root of 1 minus x squared here. Then we can to simply know that the integral need to be 1, then we can calculate that this need to be 1 minus pi, 1 over pi. Then by the same way, we can calculate the expectation of x. The only thing we need to do is that we need to plug in x in the density function, and we integrate the same scope of x and y. And we need to calculate this integral, but we know that this is the old function, and the scope is from -1 to 1. We know that the result need to be 0 by this case, because this is the old function. And we know that x and y are symmetric. So basically, ex and ey both equals to 0 by this case. And it's very simple to focus on the x and y. X is not based on y, so we know that exy is just basically ex, and ex given by big Y is the variable, so we know that they are the same. We just need to write down the 0 by this way. And as I said, they are x and y are symmetric, so expectation of y given x is 0. And the next question is to identify whether x and y are correlated or not. By this case, we use the same trick as above. We need to define whether fxy is equal to fx multiply fy or not. So that's our goal, to identify whether it's correlated or not. Then we need to calculate fxx first, because we know that fxy for now from the previous problem. And basically the fxx is just a marginal distribution. We just need to integrate based on the y, then we can get the result and we know that the scope of y given by x is this way. Then we can get the result of xxx, and xy are symmetric. Then we can directly write down the fyy, use the same method. And we know that expectation of, so by this way we know that fxy is not equal to fx multiplied by fy. And we also need to calculate the expectation of xy. We only need to plug in xy by this case, and the fxy is just 1 over pi, and we use the same scope. We know that this is also a odd function. We know that the result needs to be 0 by this case, and it's very easy to find out that expectation of xy is equal to expectation of x multiplied by expectation of y. Therefore, they are uncorrelated because the expectation is the same, but they are not independent because the fxy, the density function, is not the multiplication of two separate variables. And that's all for this problem because we use the same method as mentioned above. It's very easy to solve that. Thanks for listening.